So example number 35, we'll be told to integrate from the interval 0 to 1 in bracket 3x plus 1 all raised to power 5 with respect to x, isn't it? Now from here, you simply see algebraic substitution is working out. If you substitute 3x plus 1 to be u, you are able to get the u to be the x, isn't it? Are we together? So if you let u to be what is inside the bracket to be 3x plus 1, if you differentiate u with respect to x, if you differentiate 3x, you get 3. If you differentiate 1, you get 0, isn't it? So you take the x the other side, then you end up with the u is simply 3dx, isn't it? Are we together?
Yeah.
Meaning, where there is 3dx, we put the u, isn't it? Is that okay? So that is the same as bringing 3 this side, isn't it? It's the same as dividing both sides by 3. So that you get a third du is equals to, meaning where there is dx, you are going to put a third u. A third is a constant will be factorized outside, isn't it? Is that okay? Then where we have 3x plus 1, we put u, isn't it? So it means when you are integrating, you first integrate it without using the limit. So when you are integrating 3x plus 1 raised to power 5 dx, do the algebraic substitution. 3x plus 1 is u, meaning it is u raised to power 5 dx. You found is du over a third du. A third is a constant, you take outside, then du. A third du is dx, 3x plus 1 is u. So you see algebraic substitution, you are able to get a polynomial function, isn't it? Are we together? You are able to get a polynomial function. So from there you have a third, then you integrate u raised to power 5, you simply add 1 to the power, then you divide by the resultant power, isn't it? That is how we do a polynomial integration, isn't it? Then you go back, what was your u? So it is now, here we have a third divided by 6, isn't it? A third divided by 6 is 1 over 18, then u raised to power 6. What was u? U was 3x plus 1 raised to power 6. Are we together? Is that okay?
Yes.
Yeah, so you see, u was raised to power 5. If you integrate it, it's 5 plus 1, then you divide by the resultant power, isn't it? And remember, u was 3x plus, so you substitute back your value of u, which is 3x plus 1. So when you are told here to integrate from 0 to 1, 3x plus 1 raised to power 5 dx. Then when you integrate, when there is no limits of integration, you found what? You found this is indefinite, meaning if you put the limits of integration 0 to 1, then you're supposed to get that, isn't it? Meaning you found this is 1 over 18 into 3x plus 1 raised to power 6. Then this one we are integrating within the limits 0 to 1 because they are the original problem, so you put your limits. Are you seeing how it is simple? The original problem, you transform it back, but you use algebraic substitution in between. Is that okay? So can you substitute the upper limit and lower limit? Upper limit minus lower limit when x is 1. Where there is x, if you put 1, what do you get? Where there is x, if you put 1, so you get 1 over 18, then this is 9 raised to power 6, isn't it? Calculator, when x is 1, what do you get with the upper limit? 1 over 18. 0.5. That is what it has here. That is what it has here. I've confirmed it, it is exactly the value, isn't it?
Yes.
Then when x is 0, where there is x, if you put 0, what do you have? What do you have? Here I have 2592. Isn't it? 2592. So this minus this, what do you get to be your answer? 29,524.5 minus what you found, you get 26,932.5, and you've actually evaluated that given integral within the given limits of integration. So that's how we deal with cases of definite integrals using algebraic substitution.